this one. So please find this quotient. Over 3 minus I take the square. So please find the quotient of this number. Everyone, please do this exercise here, right now.
Okay.
So is there anyone want to do this? Want to do this by on the class? By sharing your whiteboard? Is there any volunteer? So Sudi, your answer is, let me see, minus 1 plus 3i. Oh, it's not the final answer. It's the quotient of two complex numbers. Just write it as a plus bi. Sorry, in this form, where a and b, they are both real. They're both
Okay.
real numbers. Okay. So is there any answer? Let me see. Surely. Yeah, you're right. Just give the simplest one since they are common divisors, but common factors between 76 and 100. Yes. So
Yes.
the final answer, it might be better if it's written in minus 13 over 50. Yes, plus 9 over 50i. Yes. Okay. Yes, yes. Thank you very much. Thank you both. Then as for this exercise, do I need to give you the exact process for this exercise, or we only need to get the final answer as for this one? The final answer is yes. It's right. It's this plus this. This is the final answer. As for the process as this exercise, I will write write down very quickly. Okay. For those students who didn't get the final answers, you can follow a little bit by follow this access, this process. Yes. So since for the denominator, using our multiplication, we get it equals this. And for the denominator, for the numerator, it equals minus 1 plus I, plus 3i, yes. And then using our division law, either use the final answers or just rationalize this, the numerator, denominator. Then we can get it equals this. Since the square of 8 is 64 plus 36, yes, so it's 100. And in the numerator, it's this. Using our division law, then the final answer is this. Yes. Okay, so this is for this exercise. The solution for this one, the simple process here. And then we finish this section, the first section, which is the introduction or concept of complex numbers. Then we will go to section 2, which is the point representation of complex numbers. point representation. So what's the meaning of point representation? As for complex numbers, we can associate with the complex plan, which is to a point ordered pair. For example, for this number a plus bi, it can be determined by the pair a and b, yes, which is the real part and imaginary part of the complex number. So in this sense, we can establish a one-to-one correspondence between the points, these points, and the coordinate system, which is xy plane. I will draw a picture here. So the points here, for example, on the xy plane, AB stands, for example, then is this point. Then it can be correspondent to our number z. So it's a one-to-one correspondent. So sometimes we just write like this. Since A and B determines the points on the xy plane, it also determines the complex number here. So in this sense, we can give a one-to-one correspondence between the points in the x1 plane and the complex numbers. So if we give explicit example, for example, this is the points 4, 1, then it stands for the complex number 4 plus I. So in this case, we call the complex plane, the xy plane as the complex plane. Or sometimes we call it z-plane, since z stands for the complex numbers. And the x-axis, this is x and y. The x-axis is called the real axis. And the y-axis is called the imaginary axis. This is because each point on the real axis or on the x-axis, each point on the x-axis, sorry, this is x point, sorry. Each point on the x-axis, this is the x-axis, on the x-axis, their imaginary part is 0, okay, which means they only have the real part. So the points on this axis is real. So this axis can also be called the real axis. Similarly, as for the y-axis, as for this y-axis, the numbers on this axis only have the imaginary part. Yes. So this axis can also be called imaginary axis. So this is the point representation. After this, after we have the point representation, then we will introduce another concept, which is unique, which is different from the real numbers, which called absolute value. So first, we'll give the concept of absolute values. So the definition of absolute value is like this. Oh, sorry. Sometimes we also call it a modulus. Of a number z written as a plus bi. It's denoted by this. This means absolute value of the number z, and it's given as the square root of its real part and plus the square of its imaginary part. So this is the definition for the absolute value of a complex number. So as for this, if we draw a picture, also on the complex plane, using our point representation, we have, well, first I will read this. So now also on the, if we see the pictures, view the points, the complex numbers as a point on the xy plane, then, for example, this is z here, and it equals this point AB. Yes. Then, if we draw a line segment between 0, this is 0, yes, 0 and the point z. As for this line segment, using the Pythagorean theorem, we know that since the length of this line segment is A, the length of this line segment is B, yes? So we know the length of the line segment, this line segment, oh, sorry, I will use another color. The length of this line segment equals what? It's also a square root of a square plus b square, yes? So now we can see the distance between z and 0 equals the absolute value of the number z. Yes, since using the definition, we know the absolute value of z equals this. So it's also the distance between z and 0. So using this, we can get the geometric meaning of the absolute value. So the geometric meaning of absolute value means here, since z minus 0 equals z, yes. So the absolute value of z equals this one. So this is equals the geometric meaning is the distance between z and 0. Yes, so this is for z and 0. Similarly, we can also give the distance between 2 points or 2 complex numbers. For example, this is z1, this is z2. Sorry, this is a line segment. Then we have the distance between z1 and z2 equals the absolute value of z1 and z2, where z1 is this point and z2 sorry. So the meaning of this is the distance between z1 and z2 on the complex plane. So this is the geometric meaning of the absolute value. So this geometric meaning of absolute value between two numbers is very useful in describing certain curves in the complex plane. So for example, this equation, we can see all the numbers satisfy this equation. This is an equation. All the numbers satisfy this equation. It's a set. So it also actually this is a circle. This is a circle. So what's the meaning of this one? If we suppose some number z satisfy this equation, which means on the left of this equation, on the left of this equation, what's the meaning of the left? This is the absolute value of z plus I, yes. So the geometric meaning of this is, since it equals z minus I, its absolute value, this equals this. Then what's the meaning of this one? What's the meaning of this one? Geometric meaning. Using this, then you can see the left expression means the distance between z and minus I, yes. So here is minus I. So the distance between z and minus 1 is the meaning of the left. And what's equals what? On the right, it means equals 2. So the meaning of this equation means the distance between z and minus I equals 2. Yes. So what's this? What's this set if on our complex plane? What what's the point whose distance from minus I is